Good morning, my pre-calculus class. I hope you guys are having a great day. I hope you guys have been working hard, and I know yesterday's lesson was kind of long and lengthy, so this one should be pretty short and sweet. For today, we're going to just build on what we did yesterday and using these more like in story problems or diagrams. So today you can need paper, pencil, scientific calculator where you can get that from calculator.net. That's a free one for you guys to use. Then tonight's homework is homework 61, lesson 8.2b. It is online and it's only 3 questions, and it is the same 3 questions that we're going to do today in the video. It'll be different numbers, but it'll be the exact same setup. So I want to make sure that you guys understand how they work and what they're looking for. Alright, so we're going to go ahead and get started. Okay, this is our first triangle situation that we're going to deal with. So if you need to take a moment to pause your video so that you can draw the diagram, that's great. I'm going to read some information to you, and as I read it, I'm going to input it. So if you need to pause along the way, please feel free to do so. So in this story problem, they're going to be talking about finding the length of a ski lift. So what we have here is a figure below, and this figure here is talking about there's a mountain up here. There's a people on the ski lift here at Q, and they're taking a ski lift down here to P on the ground. So what's happened is we're going to find the span of this proposed ski lift from point P to point Q. It says the surveyor measured angle DPQ to be 25 degrees. So angle DPQ, he measures right here, this angle, to be 25 degrees. So this is angle DPQ, and the surveyor says this is measured by 25 degrees. Then he says he walks a distance of 1,000 feet from P to R. So from P to R is 1,000 feet. Then it says he measures the angle from P to R to Q. So from P to R to Q, this angle right here, he says is 15 degrees. All right? So they want us to find the distance from P to Q. So we have to find PQ. This is what we're looking for. All right, so to get started, we have to figure out a couple of things that we need to do first in order to get started in this problem. So the first thing we need to know, in order for us to use this distance in here, we would need to know the distance we'll measure Q, this angle Q up here. We got to know how big angle Q is. That's one of the values we're going to need because it is opposite of our 1,000 feet. And we also have angle R over here, which is 15 degrees. And opposite of angle R right now is our mountain or our ski lift. So take a moment and copy this diagram down, and then we'll get started. Okay, so I hope you've had a moment to write that down. So here we go. We're going to go ahead and get started. All right, so since we got to go find angle PQR, in order to know that, we'd have to know 2 of the angles in the picture. And currently we only know one inside this triangle inside, which is 15 degrees going to angle R. So to find angle Q, we would have to also know angle QPR. So we're going to write that down. First thing we need to do is to find angle QPR, which is basically where you see the P at. Remember, that's the vertex from geometry. So what we should know here is that angle DPQ plus angle QPR is equal to 180 degrees. We know this because this angle right in here, for the pencil, this angle here and this angle here sit side by side. They're adjacent and they make a straight line, which makes them supplementary angles. So these angles right here are supplementary. We learned that in geometry. These are supplementary angles, and supplementary angles are 2 angles that add up to 180 degrees. Well, angle DPQ is equal to 25 degrees. Angle QPR, we'll just say angle Q. Angle QPR, we do not know. We add those together, we get 180 degrees. So I keep saying angle. So we're going to subtract 25 from each side. So 25, minus 25 plus angle QPR is equal to 180 degrees, so 25 degrees, minus 25 degrees. Alright, so then we're going to go ahead, 25 minus 25 goes away. This is angle QPR, and it'll equal 180 minus 25 degrees, which is 155 degrees. Alright, so now we're going to go ahead and write that up in there. We're going to write that in that spot up in here. Let me go get this little color here. This angle right here is equal to 115 degrees. Alright, so now we're going to use that to help us find angle Q. So bring this up. So second, I'll bring it over here. We're going to find angle Q. Alright, to find angle Q, we do angle R, which is 15 degrees, plus angle QPR, which is 115 degrees. We'll add it to angle Q, and it should equal 180 degrees. Remember, this is our rules for the law of triangles. So we'll add our 15 plus our, oh, I put 115. Oh my gosh, I copied this wrong. 155. It did not look right. Alright, so we're going to add 15 plus 155 together, and we're going to get 170. So 170 plus angle Q is equal to 180 degrees. Alright, so now from here, we're going to subtract 170 from each side. Alright, and then these cross out, leaving me with angle Q is equal to 10 degrees. So angle Q way up here, that little guy right there is 10 degrees. Alright, so now what we are trying to find, if this is big R, we're trying to find the ski lift, which this is our ski lift right here. That's your ski lift. And that's going to be represented by little r. So we know big Q, and we know little q, and we know big R, and we need to find little r. So then we're going to use those sign ratios. So using ABC from yesterday, we're going to use PQR today. So we're going to do the sign of big R over little r, and the sign of big Q over little q. Alright, so now we're going to substitute in what we know. Big R in the picture up above is equal to 15 degrees, so the sign of 15, over little r, which we're trying to locate. This will equal the sign of big Q, which we just found to be 10 degrees, over little q, which is 1,000 feet. So now we're going to go ahead and cross multiply. R times the sign of 10 is equal to 15, 1,000 times the sign of 15. Alright, so from here, we'll put this up on the screen. So now from here, tell me, what do you think we would do? That's right, Abby, we would divide on each side by the sign of 10. Beautiful, beautiful. Alright, so we're going to divide on this side by sign 10, and on this side by sign 10. So these sign 10s cross cancel out and leave me with little r, which we're trying to find. This represents again our ski lift. It's your ski lift. So we're going to break out that rusty trusty calculator. If I can put them in view here, you can see them okay. So I'll hit my fraction bar. 1,000 times the sign of 15, and we'll go down and put it over the sign of 10. Close it out and hit my equal button. Then we'll round this to 2 decimal places. So 2 decimal places would be to the 47. Since the 9 to the right is 5 or bigger, it makes the 47 go up 1 higher to 48. So our answer would be 1,490.48 feet. So 1,490.48 feet. This would be my final answer. So basically what they were relying on you to do in this problem, we're going to do a quick review, run back down. They wanted you to be able to first identify supplementary angles, And then from there, use your law of triangles to add the two angles that you have and subtract from 180 to get the missing value. And then from there, use your law of sines. All right, so this is question, the first type of problem you're going to see on tonight's homework. All right, we're going to move on to the second type. Okay, we're going to go ahead and move on to our next example that we have. Here in this problem, we're going to find the height of an airplane. So they're going to ask us to find this, which will be our height h. So from here, we have an aircraft. This is my airplane, so no, we joking around. I'm not a good aircraft drawer. It's spotted by two observers. There's observer number 1 at P, and observer number 2 is at point Q. And these two observers are 1,000 feet apart. So from point P all the way to point Q is 1,000 feet. All right, so that's our distance between the two observers. Now, each observer is looking up at the plane that they have sighted at an angle of elevation with a given angle. So observer 1 is looking up at a 40-degree angle to see the plane, and angle Q is looking up at the angle of elevation of 35 degrees to see the plane there. So we got to find how tall this plane is. All right, so the first thing we have to do is we've got to be able to figure out how big is this angle R, this whole entire angle. So I'm going to make a little dot, dot, dot. We need to know first how big this whole angle is, because we're going to need that whole big angle information in a little bit. That's going to help us out. So to find that information, we can find, since this is making a right triangle, I know 40 degrees and I know 90 degrees. So in every right triangle, the two non-right angles, or the two angles that are not the right angle, are complementary angles, which means this angle and this part of the angle up here add to be 90 degrees. So to find this portion right in here, just that little piece right there, we do 90 minus 40. And that's our angle PRD. So 90 minus 40 is equal to 50. So this angle right in there is 50 degrees. This little part right there is 50 degrees. And we're going to do the same thing on the right side. So to find this angle in here, we would take 90 minus 35, and that would give us 55 degrees. So this angle right in here is 55 degrees. Now we can find the whole angle R by adding 50 plus 55, making this whole big angle equal to 105 degrees. All right, so far so good, I hope. So that was just using basic geometry that we used back in the 10th grade. I know, I'm bringing the old school back to you. All right, so now we're going to use finding little b. Well, little b is, we're using height. Remember, you can tie that back in a little bit. For height is equal to little b times the sine of a. And you're like, well, I don't see a, b, or c here. You're right, so we're going to use alphabetical. So p comes first in the alphabet, so it'd be a. Q comes in the alphabet second, so it'd be b. And R comes after that, so that R will be c. So now we've got our ABCs. So now we can help use the same stuff. So little b, remember, is opposite of big B. So opposite of Q is here. Is our distance right in here, which over here we're going to come across and find it. This is little b right there. All right. And then, so to find this, we need to know angle A and little b. Well, we know angle A, it's 40 degrees, but we do not know little b. So we're going to have to use our law of sines. So we know the sine of big B, which is 35 degrees, over little b, which we do not know. Well, the only angle that we know, the angle and the side opposite, is angle C up here, which is R. We know that's 105 degrees, and the side opposite is 1,000. So that means the sine of 105 degrees over 1,000. So from here, now we're just going to do our lovely cross multiplying. All right, we're going to do B times the sine of 105 is equal to 1,000 times the sine of 35. All right, so Jaden, what do we do now? That's right, we divide by sine 105. All right, then these sine 105s cross out, so then we're going to get an approximation for the little b. So we're going to go ahead and put this in our calculator. So I'll bring this up here so you can see. Go this way with it, I guess, that way you can see. Okay, I'll bring this over this way, and flip it this way, maybe? Okay, so we're going to put our fraction bar in, so 1,000 times the sign of 35, and then we'll put this over the sign of 105. And then we're going to round this, not round this, we're going to write down what we see, because in the directions it's going to tell you not to round until the final end. So if it tells you not to round, you have to write down everything you see in the screen. So everything I see in the screen is 593.8100, 8100, and 222. Alright? So from here, I now know my formula. Remember, angle A we said is 40 degrees. We'll bring this up a little bit so we don't lose everything. Alright, we're going to flip this out. So then my height is going to be equal to little b, which is 593.8100,222 times the sine of big A, which is 40 degrees. So all we got to do is put this in our calculator. Well, since this is already in my calculator, this 593.810000, all I have to do is type in times the sine of 40. I don't have to retype it, it's already there. And then I'm going to round this to 2 decimal places. So 69 is my second decimal place, 9 is. The 3 to the right is not 5 or bigger, so it stays 69. So my answer would be 381.69. So my height would be equal to 381.69 feet. Alright, that is our second example. We only have one more to go. Alright, so here we go. Okay, here goes our final example. Alright, so don't be laughing at my drawing. This is supposed to be the Leaning Tower of Pisa. I know we don't be looking like that, but I know you guys got my back. Alright, so we're going to find the information here we're going to be looking for. So this is the famous Leaning Tower of Pisa. It was originally 184.5 feet tall. This will be given to you in the diagram. At a distance that was 123 feet apart from the base of the tower to the angle of elevation, which was 60 degrees looking up to the top of the tower. They want us to find the measurement, so we have to go find angle RPQ. Angle RPQ. Write that down. RPQ. So we're going to find angle RPQ. And they also want us to find the perpendicular distance from angle R to side PQ. So these are the two things we're looking for. So we're trying to find angle RPQ. So if we go from angle RPQ, that's this angle right here we're trying to find. And they want us to find the perpendicular distance, which means that's our height that we're asking us to find. Alright, so okay, so I'm hoping you got all that, so I'm going to repeat it just in case there was a small glitch in the computer programs. I want to make sure you heard everything I said. If so, you can fast forward this again. This is our Leaning Tower of Pisa. It said the distance from to P, which is the height of the Leaning Tower of Pisa, was originally 184.5 feet. The distance from the base P to the observer looking up at an angle of elevation of 60 degrees was 123 feet. They want us to find the angle PQ, angle RPQ, angle RPQ. They want us to locate this value, and they want us to find the perpendicular distance from point R to side PQ. Now, I told everybody again that since we were dealing with ABCs and not PQRs, we went ahead and remember P comes first alphabetically, so it would be our A, followed by Q, which would be the same as B, and then R, which would be C. So that way you can kind of deal with them this way. That might help you out some in what you're dealing with. Alright, so let's go ahead and figure out what we first need to do here. So let's go ahead. If we're going to try to find this angle value here, angle P, let's look and see what we could do in regards to finding this value. If I knew this value, I would have to know something across from it. And I don't know anything across from it. But I know something across from R, and I know QN across from Q. So if I went and found the whole angle R first, and then I knew angle Q, I could add these two and subtract from 180 and go find angle P. So we're going to set it up that way. All right, so we're going to use that log sign. So we're going to take the sine of Q, or sine of B, however you want to say, which is 60. And directly across from that is the side 184.5. So we know the angle and the side opposite of it. For the next part, we know the side 123, but we don't know the angle opposite of that, which is big R, or C, whichever you want to use. So now we're going to cross multiply sine of R times 184.5, so 184.5 times the sine of big R, and this will equal 123 times the sine of 60. Alright? We're solving for big R, so we'll divide on each side by 184.5. Alright? The 184.5's cancel out, leaving me with the sine of R. It's equal to 123 times the sine of 60 all over 184.5. Alright, so now I'm going to bring this up. Remember we said if we want to find an angle, we have to use that arc sign. So we're going to do angle R. We're going to use the arc sign. And then we'll put in our fraction. 123 times the sine of 60 over 184.5, and then close this out. And then we'll go ahead and round our angle measure out to 1 decimal place. Alright, so we'll go ahead and bring our calculator in here, and we're going to put that in our calculator. Arc sign, so shift sign. I'll put my fraction bar in. So I have 123 times the sine of 60, and I'm going to put that over 184.5. Arrow over. Oh, arrow over. Oh, we went too far. I gotta go further. Sorry guys, I did wrong. Oh, my bananas. Sorry. Close out my parentheses. Oh, bananas. I'm just gonna put this back in again. Shift sign, fraction bar, 123 times the sine of 60 over 184.5. Close it out, and then hit my equal button. Alright, we're going to round this to 2 decimal places. So we're going to get 1 decimal place, I'm sorry. Angles are to the 10th, sides are to 2. So 35 point, this is 1 decimal place is 2. The 6 is 5 or bigger, so I round that 2 up to a 3. So 35.3 degrees. Alright, so now I'm going to take this calculator out of the way for a second, and let's look at what that means for us. Alright, so that means this whole angle up here, angle R, this whole big angle right there is 35.3 degrees. Alright, so now the first thing is they want us to find angle RPQ. Angle RPQ. If I know 2 angles in a triangle and I need to find a third angle, I can use that triangle angle sum theorem or the law of triangles I told you yesterday. So we'll take our 60 degrees plus our 35.3 degrees that we just found, plus angle pretty much P we're looking for. It will equal 180 degrees. So we're going to add 60 plus 35.3, we'll get 95.3 degrees plus angle P equal 180 degrees. Alright, we're going to go ahead and subtract our 95.3 degrees from each side. I'm glad you guys are following with me today. Scratch these out, we'll get P. So then we're going to subtract 180 minus 95.3 degrees, and we'll get 84.7 degrees. Alright, so now we know the first answer we're looking for, which was this guy right here. He's equal to 84.7 degrees. We found the first component. So now we got to find our height. So remember, opposite of big B is little b. So this means this distance right here is your little b. And we just found angle A, which is, remember, P is the same as A. So now we're going to use our rules that we've been doing. So remember, to find our height, it's little b times the sine of big A. Well, little b is at 180.5 feet times the sine of A, which we just found to be 84.7 degrees. So all we have to do is put in our calculator, figure that out, is 184.5 times the sine of 84.7, close it out, and then we're going to round this to 2 decimal places because this is length. So 2 decimal places is a 71. To the right is a 1, which is not 5 or bigger, so it stays 183.71 feet. Alright, that is the end of our lesson today. That's everything that you need to know. If you have any questions, please feel free to reach out to me. I'll be glad to help you. This is yesterday's lesson, and today's lesson is the only thing you guys are going to be doing all week long. Have a fantastic day.